Hello, Mr. Gazda here, Homework 271, Hertzsprung-Russell diagram coloring. This is in the reference table, page 15. It doesn't call it that, but that is the name of this. It says characteristic of stars. We'll be coloring this. First thing I recommend you do is to tear them apart so it's easier, so less flipping back and forth. That's how I designed this, but please make sure you restaple it at the end. Here we go. So, look at this. Stars emit colored light. So stars, the light of different stars are different colors. A star's color depends on its temperature. Temperature matters. Color this little symbol for each of these stars with its appropriate color. And here are our four stars. Here we go. The colors are labeled here. Blue, these are all blue-white. These are kind of the white stars. These are the yellow stars. Orange, red. Please notice our sun is in the yellow stars, and it makes sense to you. You see sunlight to be yellow. Okay, so first one, Spica right here. It's going to find it on there. We're coloring it with its color, which is going to be blue. So I get out a blue colored pencil, and I just kind of color it in just like that. Okay, that's for the first one. Second one is 40 Eridani, and that's right here. Okay, that color is like a blue-white. So maybe you just do like a light blue. It's hard to do blue-white, so I'm just going to color it lightly blue. Hard to do. Maybe some people often will use a darker blue for this one just to differentiate, but that's fine as long as you get the point. Proxima Centauri is going to be the next one. Okay, that's this one right here, the next one. Therefore, that's going to, we got to find that. Look around. Find that. That's right here. So that's a red star, and you're going to use a red colored pencil. If I can find one. If I can find one, I'm going to use this. I have a pen here. Red. It is important to use the right color. I shouldn't need to say that, but next one, Polaris, the North Star. Polaris. What color is Polaris? Go down here. Yellow. So get some yellow. Color that in there. Yellow is a little hard to see, but that's what you do. So that helps you understand the color of the stars on this chart. There's a lot on this chart, and the coloring really helps you just sort of make sense of it. Circle all the main sequence stars with a blue pencil. So I'm hoping that when people did this, they were sort of to really understand what this is. These stars up here are the supergiants, this whole area here. These are the giants, this cluster. White dwarfs are here, and main sequence stars are kind of this whole area here. So if you, basically what you do when they plot the temperature of the stars here, and this goes actually from lowest to highest this way, which is odd, and then luminosity, which I'm going to say brightness of the stars from low to high. If they were to do that and plot, you know, the stars, you get these clusters or groups of stars, and all of these are main sequence. We're going to kind of call these like an average, so the average star. Our sun is one, just an average main sequence star, and we're circling them with a blue pencil. So let me use, is this one blue? Yeah, so what I mean by that is just kind of this, circle that with a blue pencil. It's this whole area is the main sequence stars. Okay. Varying temperatures, you can see, and even luminosities, but so those are our main sequence stars. That is number 2. 3, circle the white dwarf stars with a brown pencil. So let's see where the white dwarfs are. White dwarfs are here. Okay, so these here are white dwarfs, brown. You know, not super perfect, just get the idea. White dwarfs, brown pencil. There we go. Next up, that was 3, now we're on to 4. Lightly shade all stars with luminosities more than 10,000 times brighter than the sun, yellow. That's right, 10,000 times brighter than our sun. That's really hard to think about, but cool to think about. We are shading them all yellow. So what are we doing 10,000 or more? So what this is, for luminosity, what it basically does is if all these stars were the same distance away, okay, they're all with the same distance away, how bright would they be? Because if the further away it is, it looks less bright to us. So what they decided when they came up with the scale of let's make the sun 1 and compare everything to the sun. So therefore, these here, anything here is 100 times brighter than the sun if it was the same distance away from us. these here, 10,000, anything here, 10,000, 100,000. This is 100,000 times brighter than the sun if it was the same, if it was right next to the sun. That is amazing. But all of these here, okay, are 10,000 or more. So I just kind of, my idea was just kind of shade this here. All these stars right here. Kind of just shade over them. Doesn't have to be perfect. Don't color each individual one. All these stars here are 10,000 times brighter than the sun. I love the thought of that. It's really hard to wrap your brain around. Okay, so what I have here is next one. 5. Use the chart to put these stages of a star's development in the proper order. Hint, the first stage is nebula. So nebula is the first stage. I give you that hint. Beginning, final stage of a sort of a life cycle of a star. They're not alive, but they kind of go through this, they go through all these steps during their existence. But the first step is nebula, so that's good that I give that to you. And that a nebula is a gas or dust cloud, please know that. A nebula is a cloud of gas and dust. I'm going to point that out. Nebula is a gas and dust cloud. Then, how do I know what comes next? Main sequence, white dwarf, or supergiant, giant star? Well, what they have on the reference table, look at these supergiants, intermediate stage, giants, intermediate stage, white dwarfs, late stage, main sequence, early stage. Those are your hints. Okay? Intermediate, in between. Early is towards the beginning. White dwarfs towards the end. Therefore, what you're going to get is nebula, then after, once it first becomes a star, it becomes a main sequence star, because that is the early phase, main sequence. And then you have the supergiant or giant phase. And the final stage is white dwarf. So, as you probably can deduce, the giant stars are really big and supergiants are even bigger, but this, so you go from sort of a regular star like our sun, they get bigger for a time period, and by time period I mean billions of years, and then towards the end of their existence they will become a smaller star, dwarf being a much smaller star. So that's kind of the stage here, and this takes, you know, billions of years, 6, 7, 8 billion years to go through this series of phases. So we're talking a long period of time. That's a billion with a B, so that's a long time. 6. Which of the following stars is hottest? Of these three, what you want to do, the temperature is here. These are all in Kelvin, okay, measurement, not Celsius, not Fahrenheit, but Kelvin, and it goes up this way. So let's compare them. And once you compare Procyon B, Betelgeuse, and what's the other one? And the Sun. Right, we're doing the hottest of these, the hottest. So we want to do this way. Procyon B is in the range of 9,000 Kelvin. All right, that's the answer for 6. Okay, and then number 7. Which of these stars is brightest? And by brightest, I'm calling it highest luminosity. Of these three, let's look them up. By brightest, we're going to look on a luminosity scale up towards the top. Okay, and what you're going to see are, we're looking at this one, Deneb here, and Alpha Centauri, which is there. So this here, we're in the range of over 100,000 times brighter than the sun. Amazing. But so that is definitely the brightest of those three. Which of these stars is white? Looking at the color, here we go. We're looking at white right here. We're going up the chart, and it's going to be Sirius. Okay, because it's kind of in this range, close to white, blue-white, but that's the best answer. Sirius. People recognize that name from Satellite Radio Company, which was named after this star. 9. Circle the correct answers. Okay, so it's kind of multiple choice. Compared to the white dwarfs, giant stars are they cooler, hotter, the same temperature, and have higher or lower, same luminosities? Okay, so I'm comparing white dwarfs and giant stars temperature-wise. White dwarfs and giant stars. White dwarfs are here, giants are here. So, white dwarfs are going to be hotter. If you look, the scale goes this way. White dwarfs are hotter than giants, so the first... I'm sorry. Yeah, white dwarfs are hotter, giants are cooler. So, compared to white dwarfs, giants are going to be cooler. and compared to their luminosities here, giants are higher up. White dwarfs are down here, so these are kind of not as bright. So giants are going to be brighter, which would mean in this case a higher luminosity. Okay, so you got to circle those two. 10. The hottest main sequence stars are what color? So now I'm going along here, okay, and the higher temperatures are over here, and they're going to be blue. The hottest main sequence stars are these, and they're blue color. Blue. Name 2 stars that are lower temperature than Pollux. Okay, so Pollux is here. Therefore, any 2 you can write. Aldebaran. Okay, cool. Anything on this side. Betelgeuse, Barnard star, Proxima Centauri. Okay, 2 of those 4. Again, this one, Proxima Centauri, Barnard star, Aldebaran, and Betelgeuse. 2 of those is what you need, and that will work. 12. Draw a line graph of the main sequence stars only. Low temperature to high temperature luminosity. So I have low to high here, which is reverse here. Now it has to go this way. So this requires some thinking. And we're doing luminosity. So for these main sequence stars here, as the temperature goes up, what happens to its luminosity? It goes up as well. So as I go this way, it gets more and more higher luminosity or brighter. Therefore, so basically higher temperature, higher luminosity. Therefore, it should go, low temperature, low luminosity should go like this, and check. Low temperature, low luminosity, high temperature, high luminosity. All right. That can be confusing because this graph is chart is done the other way for some reason. And then 13, put these in the proper order, lowest mass to highest mass. Please note that this stuff, how do you know how big it is, how much mass it has? Smaller, more massive. Smaller stars, bigger stars. Makes sense. Dwarfs are smaller stars. Giants are big stars. Supergiants are even bigger than giants, hence the name. Therefore, you have to look at these, and you have your Proxima Centauri down here, smaller stars, and then what do we have? We have 4 of them, and then the next one is going to be Sirius, which is here, and then Aldebaran, and then Rigel up here. Okay, so it goes like this. Proxima Centauri, then Sirius, then and then Rigel. Okay. So, hopefully, if I did this right, you should have a good sense of all the parts of this chart right here. Okay? Thank